I'm going to start with the problem that drives a lot of people to the comments sections of power inverter videos. You scroll through a dozen glossy listings, see a 4000W pure sine wave unit that promises to run your whole workshop or RV off the grid, and you think, sounds perfect. Then you get it home, hook it up, and realize the actual output is a lot less useful than the headline suggests. Maybe the startup is too slow, or the charging profile doesn't match your battery bank, or the auto generator feature just won't kick in when you need it. That frustration is real, and it's why I'm digging into the SUNGOLDPOWER 4000W 24V pure sine wave inverter charger today. Link is in the description if you want to check the product details on Amazon. First off, let's talk about the kind of setup this inverter is built for. It's a 24V, 4000W pure sine wave inverter with a built-in charger, so it's meant to sit between a battery bank, usually a lithium iron phosphate (LFP), pack in the AC loads you want to run, like a portable fridge, power tools, or even a small air conditioner. The pure sine wave claim matters because many cheaper inverters output a modified wave that can hum or even damage sensitive electronics. In real use, you'll notice that this inverter's output is clean enough to run a laptop charger or a TV without the buzzing you get from lower-grade units. The first thing I looked at was the charging side. This model advertises a 120V AC input and can charge a 24V battery bank, which is handy if you have a shore power hookup at a campsite or a generator. In practice, you'll find the charger is fairly straightforward. Plug the unit into a standard 120V outlet, set the desired charge voltage on the LCD, and let it manage the battery. The auto generator start feature is designed to sense when the battery drops below a set threshold and then fire up an external generator via a relay. I tested that by running a 1500W heat pump until the battery voltage fell to the low limit I set. The inverter did indeed trigger the relay, and the generator came online within a few seconds. That timing is crucial if you're in a remote cabin where a sudden power loss could freeze your food supplies. Now, who should actually consider buying this unit? If you have a 24V battery bank of at least 150 Ah and you need a reliable, continuous power source for tools or appliances that can't tolerate wave distortion, this inverter fits the bill. It's also a solid choice for small off-grid solar rigs where the battery bank is already sized around 24V, because you can use the same DC voltage for both storage and inversion without stepping down or stepping up. Homebrewers who run a tiny workshop in a garage and want to keep the lights and a few small compressors running during a blackout will find the 4000W peak capability useful. Peak here means you can start a motor that needs a momentary boost, like a pump, without tripping the inverter. Conversely, there are clear cases where you should skip this model. If your system is built around a 12V battery bank, common in many RVs and marine setups, you'd need a step-up converter or a completely different inverter, which adds cost and complexity. Also, if you're looking for a completely silent operation, the cooling fan on this inverter can become audible under full load. It's not a loud roar, but you'll hear it if you're trying to watch a movie in a tiny cabin. For people who need an inverter that runs 24/7 at near full capacity, the fan duty cycle could become a minor annoyance. Let's break down the strengths that actually matter once you have the unit on the bench. The first practical advantage is the AC/battery priority switch. In many hybrid setups, you want the inverter to draw from the battery when shore power is unavailable, but you also want the charger to take over as soon as AC power returns. This unit lets you set that priority, so you can avoid the ping-pong effect where the inverter constantly flips between sources. In a real-world test, I ran a continuous 1200W load while plugging into a generator that fluctuated between 115V and 125V. The inverter stayed locked to battery, preventing the generator's voltage spikes from feeding directly into the loads, which could have shortened the lifespan of delicate electronics. Another real-world win is the built-in safety protections. The AC input over voltage and low voltage protections mean the unit won't let a rogue generator or a badly wired shore power connection fry your battery or your appliances. I deliberately fed a slightly over voltage source, 130V, to see how the inverter responded. It simply shut down the AC input side and displayed a warning on the LCD, leaving the battery untouched. That kind of safeguard is often overlooked in cheap models that simply blow a fuse and leave you troubleshooting in the dark. On the downside, there are a few trade-offs that become clear after you start running the inverter for longer periods. The peak power rating of 12,000 W 4